Hey everyone, welcome to Data Elevate Hub. In today's video, I'm going to explain about Python and its internal working. Let's start. So Python was created by Judo Van Rosso in the year of 1989 and it is released to the users in the year of 1991. And it is a open source software, means we can download freely and we can customize the code as well. Python works on different platforms like Windows, Mac or Linux. And Python has a simple syntax similar to the English language. Python is general purpose and high level programming language. So what is high level programming language? It is a human readable language. We can able to read the code and we can able to understand the code easily. So the other high level programming languages are C, C++ and Java. As you might infer from the name high level languages, there are also low level languages. So what are the low level programming languages? So these are the machine readable languages which are defined in bits, zeros and ones. The example low level programming languages are assembly languages and machine languages. Computers can only execute the programs written in low level programming languages. Thus, the programs written in high level language have to be processed before they can run. So this extra step takes some time, which is a small disadvantage of high level languages. But the advantages are more. So first, it is much easier to program in a high level language, and the programs written in high level language takes less time to write, and they are shorter and easier to read, and they are more likely to be correct, because here we are writing the codes in human readable language. If we are going to write the code in human machine readable language in bits, it is difficult to understand. And the second, high level languages are portable, and meaning that they can run on the different kinds of computers with fewer no modifications. And low level programs can run only on one kind of computer, and you have to rewritten or recompile to run the on another computer. Due to these advantages, almost all programs are written in high level languages. Low level languages are used only for a few specialized applications. We know that computers understand only machine code that comprises ones and zeros. Now you have a question of how these high level programming languages are converted to low level programming languages. We have two kinds of programs process the high level languages into low level languages. So those are interpreter and compiler. Now let's discuss about interpreter. So interpreter reads the high level program and executes it, meaning it does what the program says. It processes the program at a time, or it will read the lines and perform the computations. So here we have a source code and the interpreter. The source code has been sent to the interpreter will compile and execute the code, and it will result the output. Now let's discuss about compiler. A compiler reads the program and translates it completely before the program starts running. In this case, high level program is called source code and the translated program is called object code or the executable. So once we have the executable or object code, then we can execute it repeatedly without further translations, and it will give us the result as an output. So here the main difference is interpreter will execute the code once you submit it, but in compiler first you have to compile the code and then you have to execute it. So that's all about high level languages and low level languages conversion. Since computers understands only machine code, so it is imperative that we should convert any program into machine code before it is submitted to the computer for execution. So for this purpose, we should take the help of a compiler. Actually, a compiler normally converts the program source code into a machine code. But in Python, the compiler does the same task but in slightly different manner. It converts the program source code into another code called bytecode. So each Python program statement is converted into a group of bytecode instructions. Now let's understand about machine code and bytecode. So first, machine code. So machine code is essentially a machine language that the CPU can process it directly. So once we compile the code, it will create a machine code, right? So this machine code we can directly execute it in the machine, the computer, because it is already in bits, and it does not require any separate interpretation or compilation. Now let's talk about bytecode. So bytecode is generated from the compilation of source code. However, it cannot directly run by the CPU and require an interpreter for execution. So it's a bytecode is an intermediate code exists in the virtual machine. It doesn't exist physically. Okay. Now let's discuss about the internal working of Python. Now let's discuss about the internal working of Python. So now we have a Python source code and we have a OS which is either local computer or a remote server. So there we install the Python. So once we install the Python, it will install the all the components of Python like interpreter. So interpreter contains components like compiler and Python virtual machine. So once we submitted the source code and when we are executing the source code, it will be sent to the Python compiler. So it will compile the code and it will create the bytecode. It's a .pyc file. It's a temporary object and it will be sent to the Python virtual machine. So what is this Python virtual machine? So Python virtual machine takes those bytes codes and converts those instructions into machine code so that the computer can execute those machine code instructions and display the final output. To carry out this conversion, Python virtual machine is equipped with an interpreter. So this interpreter converts the bytecode into a machine code and sends the machine code to the computer processor for execution. Since the interpreter is playing the main role, often the Python virtual machine is also called as a Python interpreter. So then the result is displayed in the output. So here Python is considered as the interpreted language because Python programs are executed by the interpreter. There are two ways to use the interpreter. So one is command line mode and script mode. Let's demonstrate. Now I have opened a Visual Studio Code and Python is already installed in my machine. Let's open the command line interpreter. So for that I have to type Python. So the first line of this example is the command that starts the Python interpreter, and the next two lines are information messages from the Python interpreter. So the next third line starts with greater than symbols. There we can write the code. So let's write hello, printing hello world. Yeah, it's printed. So now we can close it by using the exit of command. So then it will stop the Python interpreter. Now let's try it with the script. Now I'm going to create a Python file. So here we have to use the Python extension sf.py. So then the machine understands it's a Python file. So now let's write a hello world program in script as well. Yeah, now I'm saving that file. Now I'm going to execute this file in command line. So here I want to execute this file using Python, right? So first I have to use the Python command and then the file name. So it executed and it printed the result. Earlier we discussed about the bytecode, right? We can display the bytecode file as well here. For that we have to use the command -m and this and the file name. So it will display the bytecode of this file, and this bytecode will be executed in the interpreter which is in Python virtual machine. Now we have seen how we can use the Python in command line and scripts. So now let's discuss about how Python is flexible when compared with the other programming languages. So if you want to print a hello world message in C or Java, if it is C, you have to define the header and you have to define the main class, and then we have to print whatever it required. In the same Java also we have to define the class, and then we have to define the main method, and then we have to print. In Python it is straightforward. Just we have to use the print keyword and we can directly print the results. Now let's take another example of sum of two numbers. So in C and Java, as it is, we have to define the headers and we have to define the main methods, and here we have to define the variables with the data types, and then we have to perform the sum operations. But in Python you don't need to define the any data types. You can directly assign the value to a variable, and then you can directly apply the transformation. Now let's discuss about the Python release versions. Currently we are in the version of 3.13. So till 3.8 the support got ended. We won't get any support from Python. And currently the 3.9 to 3.13 they are under security and bug fixes. So they will apply some patches and they will apply some security maintenance they will do. So the upcoming release version is 3.14. Next, Python supports to functional programming and object oriented programming. So nowadays to fulfill the requirement, both are required. So Python is like we can use the functional programming and object oriented programming in a single script. So we can discuss more about in the future videos. And now let's discuss about Python applications. So So now let's discuss about Python applications. So nowadays all companies are using a Python programming language to develop the standalone applications or like web applications and database applications to process the huge amounts of data like Hadoop, Spark and Kafka. We can use the Python to build the scripts using those frameworks, Hadoop framework and Spark framework and Kafka framework. And next we have machine learning. Here we can build the models using the Python language, and data science for the data analysis, and we can leverage those pandas, numpy and the scikit-learn libraries. And next artificial intelligence and IoT, internet of things. So and that wraps and let's wrap up the first part of our Python introduction. Today we have explored the internal working of Python and looked at some amazing applications of Python in various fields. So in the next video, we will dive into the Python programming basics, covers, errors and debugging techniques, and then move into the hands-on programming concepts. So if you enjoyed this video or found it helpful, don't forget to like, share and subscribe to the channel. And as always, if you have any questions or feedback, drop them in the comments below. Thanks for watching, and I will see you in the next video. And let's wrap up the first part of our Python introduction. Today we have explored the internal working of Python and looked at some of the amazing applications of Python in various fields. And in the next video we will dive into the Python programming basics and covers the some introduction concepts like what are the errors which are happening in Python and how we can debug those errors, and then we can move into some hands-on programming concepts. If you enjoyed this video or found it helpful, don't forget to like, share and subscribe to the channel. And as always, if you have any questions or feedback, drop them in the comments below. Thanks for watching, and I will see you in the next video.